Cisco, and he's going to talk about, network technology and energy efficiency. Thanks.
Yeah, good morning. Sorry, I didn't turn the mic on. Great, thanks. Okay, so I'm here to talk about Cisco and how we're operating as an entity from an organizational structure in engineering and as a company, and then go into the specifics that dive into the lower level of the actual detailed designs that we heard on yesterday. So we have a green corporate mission. That mission is in our operations, we want to impact the way in which we operate our business. In our products, we want to create efficient products. Architectures, the solutions and software basically that we sell to our customers, and then inspire our employees to actually get involved and make a difference. So our green strategy from a corporate perspective is greenhouse gas emission reduction. So obviously ICT power is high on that list. We have an operational goal, and this is in our operations directly, by 2012 to reduce our greenhouse gas emissions from a corporate footprint, not a product manufacturer or shipment perspective, but operations by 25% by 2012. So the way in which we are choosing to get there is a heavy emphasis on using our own technology to achieve that goal. We use a lot of the telepresence collaborative tools. I was in a WebEx meeting listening to a briefing for networkers in San Francisco at the end of the month. Didn't participate in the room, but I at least was aware of what the discussion points were this morning, even in this meeting. We have all of our facilities are IP enabled, and we want to make them bridged into the building maintenance systems. So today, I had this discussion at lunch yesterday. The building management systems today are all proprietary protocols, much like the internet was 15, 20 years ago. And Cisco's claim to fame was building a bridge between that. Well, that's the initial rollout of what we're doing today. We've got a company that we just acquired earlier this year called Richard Zeta out of Goleta. And the product that they make is a bridge from those proprietary building maintenance control systems into an IP translation so that we can monitor them, talk to them, hopefully in the future build communication layers through that bridge to control them, and then eventually you would hope that that power, that knowledge of those sensors being knowledgeable on a data reporting system in the ICT infrastructure would drive an IP conversion in those areas. In our labs and data centers, we're looking to reduce the power that we use, and do that with our networking control elements actually powering down systems. And changing the paradigm to always on in our labs to always off when not used. And then, of course, the area that we're focused on in discussion today is CDO's involvement in improving the product efficiencies themselves. We have active participation in many standards organizations and agencies. I think a lot of people have put banners up, and we have LVNL and EPA representative participation here in the room, in audience, in DOE. But these are the activities that we've been involved with, but there are many more behind it. There's just a plethora of activities in standardization. So in the Cisco Development Office, or CDO as we call it, our vision is to deliver thought leadership and product solutions for climate change. And again, it's greenhouse gas emissions as a corporate umbrella that we're truly focused on beyond the normal product enhancements of next generation strategies. So we're going to maximize efficiency while hopefully fundamentally driving game-changing innovation. And like I described the Richard Zeta product, that's an area of focus. So those are the types of capabilities we're going after in the future. And then we're looking to leverage the network effect and the effect that communications has on global energy management. The specific near-term tactical tasks that we're engaged in are listed here. So we have an education track, as we call it, and that's basically driving within the organization the awareness throughout all of engineering. Designed for low power, never really was a strong attribute other than in a certain class of product, and we heard some of those mobile devices obviously being battery powered were, but there's no reason why a wall-warded or IP powered phone can't have those same attributes associated with them. But nobody ever put that on the PRD before, and it's a product requirement document that we drive engineering for marketing with, and we are now templating a certain list of attributes that we're requesting marketing answer with every PRD, and we've done that since the first of this year. Basically, all engineering has to respond to this list of questions with their product, one of which is, okay, what's the product roadmap of energy use to the future? And if you're not increasing efficiency or lowering power, you need to get your VP to sign off on that and tell us why. Then in the global lab power management space, as was pointed out yesterday, a large amount of our employees are telecommuters, especially if you're in the software realm. You don't need to get in the car and drive to work every day. You can work from home. And your lab has a rack of equipment or multiple racks of equipment for you once you've compiled your image overnight, hopefully. You come on the next day and you load your image and do a unit test of your code base the next day, and your rack's sitting there powered. Well, it's powered all night while you were compiling. Why should your rack of test gear be up and running when it's not really necessary for you to use? Or why isn't India or China utilizing that rack overnight if it was powered on? So a lot of that activity is going on and coordinating with remote sites for availability of that equipment. But we really need to change the paradigm. But if you're not utilizing it, somehow either the system itself is automatically aware of the fact that the console is not logging bit rate. And if the console is not logging bit rate, you're not actively utilizing it. It sends you a message and says, hey, we haven't seen you on your console in a while, but this unit's powered up. What are you doing? And after a couple of pings like that, you get a message that says, hey, guess what? We're going to shut you down. And it automatically shuts them down. So those are the activities that we're looking forward to implementing and changing this paradigm that we've been operating in recent past. So obviously, power supply management and efficient management of power supplies, so knowledgeable power supplies that can report where they're operating, what their input is, what their efficiency is. Basically, MBus extended into power controls of PMBus, making all of our power supplies PMBus capable and reporting. But obviously, the simple task is to get the low, high efficiency at high load cases to be more efficient across a flatter load curve. That's certainly one of the areas. And then in ASIC power management, obviously there's board-mounted power that we have, and some hit on that topic yesterday. We're looking to improve the methodology of control of that board-mounted power and awareness of that control within the design organizations to affect the ASIC power management. I'll get into the ASIC power management in detail in later slides. One of the areas is product green metrics. Okay, so how do we measure all these things that we're doing here are actually making a difference and a dent in what the product we ship to our customers and the power we use internally. So there's a team working on actually figuring out the methodology to automate metrics on an ongoing monthly basis to gauge how product business units are making these changes. And then in order to make that successful, we have to have a product power profile and efficiency metric team that goes out and convinces BUs that, okay, for your product and your class of product, this is how you should measure that efficiency. And then with that data, we can enable a reporting structure in the green metrics. And then what do we actually provide to our customers? Well, it's solutions. It's software, hardware, and the mix of the two as they use them in their businesses that truly is what we are as a company. And how that solution solves their needs and problems, how can we make those solutions more efficient through the whole stack? So a large amount of the upper tracks are low level, affecting hardware in general. This is where we put it all together in the solution of a router or a switch or an access point, and deliver the network as always available. And that always available is replacing always on in what we're trying to affect. And so those architectures are what we are looking to innovate on in that track. And then, as I alluded to earlier, we have a particular track of people that are focused on industry standards and governance and how we influence those standards and how we participate in government agencies rolling out those standards in the future. So global IP traffic growth continues to march on. This is petabytes a month. As you can see, the forecast is for zettabytes to be crisscrossing the net by 2012. And large amounts of video are responsible for that transition. So you're going to see that the consumer space is predominant in the future as to what the actual traffic is going to be carried. So what we have a view is that the network has many positions. There are many applications at various locations. And as we've spoken on earlier class of products, there's utilization rates for each area. And the reality is that the access utilization rates are quite low because you choose to download an application or a web page, and then you have to sit there and digest it for a while. However, video breaks that model, and video can be and is generally today predominantly done over a broadcast network in parallel with a data network. But as that model changes, these utilization rates are going to change and go higher for the access networks. So the access concentrators generally are the next step up in utilization rates, but again, they are down in the 15% range. Between those two, the broadband access providers oversubscribe their equipment because they know that the utilization rates are low, and they can get to 20-to-1 or more in oversubscription ratios in that area because of this phenomena. And then at aggregation levels or points in metro networks, the physical links are approximately 30% utilization rates, and then IP core networks generally tend to be less than 50% utilized on link rates. And this is just a provision model of how networks are actually managed, just like any other data center utilization that we saw earlier this morning. They're under peak capacity. Now, what we're trying to affect as an overall corporation is to drive in these access networks, which are responsible for large amounts of devices, very, very high dense device aggregation. We're trying to drive on-off sleep modes, but those on-off sleep modes aren't, well, ideally they wouldn't be perceptible to anyone using the network. The network would always be available, always be on to them, or always appear to be on. But what we would like to see is if I do go into a sleep mode, then I don't have to re-register or re-authenticate my VPN, somehow prevent all that re-registration from occurring. That would be the ideal view. But today, that's not where we're at. But that's where we're striving to get to. And then in the core or aggregation area, what we're trying to do is to drive more scaling of the power required to move bit streams with the actual bit stream capacity required. So that's the goal that we have. So each one of those networks is different, and an internet is all these networks connected together through multiple hops. And you can't just come up with a typical network anecdote and say, okay, we're going to test this piece of gear against that criteria. Each one of those is distinct in its characteristics and the job it's doing. Certainly at brokerage and financial institutions, they have their requirements for networks as well as service providers have for their core versus their broadband access. They're all different. And what we are trying to do is say, look, you need to look at the function of the network, what services it provides, then what is that real power consumption, and then look at the architecture from a system-wide end-to-end service delivery perspective, and look for, holistic methodologies of driving that service delivery either in a new paradigm or in a way that affects, more efficient utilization of that network. And then once you've done that, of course, to make those changes known, you have to look at efficiency of products. And then with those efficiency metrics, you can make those determinations at that architectural level. And so the industry, like many others, like storage, like servers, is just now breaking into coming up with those metrics on a box-by-box level. So obviously these are network categories. They're disparate. One is economically driven, high volumes. Many consumer use these types of devices for network access at home. And then at the core is a high-end internet router. They're both driven by different requirements, but essentially are data throughput devices. And there's orders of magnitude. So log scale of plot that you would, compare these capabilities. And obviously, the log would be volume versus, watts and bit rate. So looking at our class of products in the enterprise and core, this is the division of actual power. You can see that it's predominantly driven by our electronic ASIC utilization. 40 to 35 to 40% is in the power distribution and conversion, as well as the cooling systems. But fully 60% or more is in the actual electronic device utilization. So we are looking to optimize these three areas as well as the software at that system optimization architecture level to try to drive these silicon requirements down. Now, the way in which we do that is we have a ASIC Low Power Council inside the company, and they're tasked with driving this ASIC Low Power design methodology across the company. We're a very rubber meets the road, cookie cutter, use what's available type of company. We are not too involved in very esoteric future technologies from a product perspective immediately. It's what, in the near term, 2 years that we can ship that we're generally engaged in. So we have a ASIC's design process low power checklist. We're referencing low power designs to other groups, so it's a cookie cutter activity, moving that from organization to organization. One of the big impediments to adoption in these areas is the actual design tools that allow our engineers to do these designs are not keeping pace with what we would like to see in availability. So we have to get vendor alignment into utilizing similar types of feature sets and similar toolkits to allow us to draw on those over and over again within different organizations. Power efficient coding guidelines, power estimation. You wouldn't believe how power estimation really does affect the entire chain, because at the core, if ASICs are overestimated in power budget, that power budget just ripples through the entire design process. And we really need to get power estimation and analysis down to a better level than just within 20%. Because if he adds 20% overhead, along the whole chain, that 20% overhead in power just ripples up to almost 50% by the time the system level design is complete. And then we're using, of course, the available voltage scaling feature sets. This is a very large view of the graphs we've all seen yesterday. As technology improves, we are getting, large-scale step improvements, but the curve is flattening out. And we all saw that in the discussions from yesterday. So in the silicon area, in architectures, we're combining functional blocks within one device that was in two before. So that's one of the areas of getting much more watts per bit efficiency. And so that integration of a two-chip solution into a single chip solution, running more cores, parallelism is the next slide that I have. Power DRAM I/O interfaces being lower power, clock gating, optimization, macros, again, recurring designs, cookie cutting across multiple platforms is a real saving for us. Then, of course, memory and core splitting power levels for those. 40 nanometer technology, obviously with future leakage correcting reduction technologies, multi-voltage and multi-gate devices, again, in the tools of available suppliers. And then adaptive voltage scaling, actually marking the part so that at the performance level that we require, we get that performance for a lower power level. So power efficient architectures are parallelism. It was briefly touched on yesterday. Funny thing is last week when I was asked to make this presentation, I went to Berkeley's CS61, got a slide deck on parallelism out of one of the lecture files, and got to the end of it, and it was a nice read to question whether or not parallelism really is the way out of this problem. It seemed like it was just a sidestep out of the problem, but for us, it actually has improved throughput for some of our products. We can run many parallel packet processors at much lower rates and solve this problem in our class of products. Our quad flow processor recently turned to multi-threaded. And then alternate technologies is obviously going into waveguides, holistic, holographic, or silicon photonics, and in a parallel of optical networks. So we've got silicon switch delay line buffers for how to delay or do memory or storage of packets through that. So in summary, internet energy efficiency in the core, we're looking to scale power throughput as it applies to network operations in the core. And in the edge, we're looking for idle on and off modes that don't or are not perceptible to the user. Internet efficiency is a very visible issue. We are broadly addressing it as a company across the entire landscape. There are hard and easy problems, and that's what we're working on. There was a recent UCSB presentation made. There are two videos there. Rod Tucker from University of New South Wales in Australia has a very interesting data that he has for analysis of points in the network. And then Gary Epps has a video on hardware much similar to mine. Here are the public links that talk about the various green roadmaps and the Green Engineering Task Force. And then our commitment to energy standards is also available on our blog space. And then for the power supply reference standards that we're working towards, it's the 80+ organization and efficient power supplies that the EPA has helped adopt and drive into the server standards. With that, I want to thank you for paying attention.
Thank you, Joe. There must be a number of questions. We definitely have room for it.
So some of us are device people rather than system people, and I'm wondering whether we have an important function here. It seems like you can make big improvements in efficiency by using common sense rather than sophisticated device design. So in your charts, if you assume that you had transistors that were 50% more efficient, would that have a substantial impact on your system? And the second question is, do you see any role for photonics in system improvements? You mentioned at the end some of these possibilities.
Yeah, so 50% improvement would obviously ripple up because, again, all the tasks associated with moving data in our equipment is heavily dependent on silicon power, and it ripples up throughout the system and architecture. So yes, saving 50%, in my opinion, would be a very good and beneficial benefit to the hardware platforms that we design. As far as how to move packets optically, we are looking at that, but quite honestly, service providers have been pretty flat in their spend on optical enablement other than for straight optical transport. So in our class of product that does packet processing through storage and forwarding, there has not been a large amount of adoption in the near term from optical transport.
So you're waiting for the vendors to come up with a...
Well, we're waiting for a solution in that space that is a paradigm shift to entice the vendors to adoption in that area. And we're participating on research in that area. And that area maybe 5 or 10 years ago was quite prevalent as a paradigm shift, but like ATM was in the 90s, it just didn't come about. And we are a very much near-term product solutions company that looks to deliver for real problems today, even though we have our visions on the horizon for 5 years out. So where we want to be in 5 years does not necessarily mean that we have markets today for those solutions.
I think it was Jonathan Kumi's talk earlier this morning where he pointed out that some organizations, and even enterprise-scale organizations, the IT organizations are not really incentivized to be concerned. They don't get hit with the cost of the power consumption, so they don't have the incentive. And I was wondering if you could validate that through, in dealing with your customers. And how do you address that? You have a big agenda here and a sort of a strategy, but if your customers aren't going to be willing to pay for it, then of course it's hard to see that benefit. So I wondered if you could talk about that issue a little bit.
Yeah, I can talk about the fact that in the last 2 years, our internal organization has looked at these structural problems, and today, IT and the facilities organization that pays for the power bills today are under the same vice president as the chief operating officer at a senior level. But WPR is under finance, and we have WPR working basically hand in hand with the organization responsible for paying the bills. IT and that organization report to the same. I can't...
You're talking about inside Cisco.
Right, inside Cisco, right.
I'm asking about your customers.
Yeah, in our customer space, it's hard for me to have that visibility directly to their organizational structure. In the Green Grid and other entities, we've talked about the disincentives and that we should be able to go after those, but it's changing organizational structures of our customer base to gain those effects. So we don't see that marching forward, at least I have not seen that marching forward in those forums as effective change in structures of IT organizations. So no, I haven't seen evidence that the organizations are changing for that.
So one of the telling numbers I saw this morning also in Jonathan's talk was this couple of millijoule per bit of the internet aggregate energy cost. That's a staggering number. So you kind of pointed out in your slide where you look at different efficiencies of the different steps. How much do you think this can be improved by basically, we're basically 18 orders away from KTLN2, right? As we talked yesterday. So what do you think? What are the low-hanging fruits in there? How much can we?
Yeah, I just wanted to tell you that this presentation has that analysis for the actual network. Okay. As it applies to data centers or servers, you know, I can't comment. I know that I don't believe those are the numbers being cited here. I think they're quite a few orders of magnitude less than that. Okay. So I would just point you to this data, and then that would be a better answer than I can do in a 30-second response.
Okay, good. One last question. Yeah, well, yell and see where you go.
Yeah, unfortunately, then the video doesn't capture the question.
It's more efficient, except for you. Can you comment on the methods and tools you're using for power estimation and analysis, and what type of gaps you have identified in the tools that are available right now?
So the power measurement from the system level is pretty basic. It's just a wall meter tied to a specific operating throughput. And so we worked within the organization called ASIC to drive a methodology for looking at network power in situ, not maximum, and not measuring maximum performance and throughput, but measuring provisioned power. So that was truly an argument within the industry. Is there were other opinions that said, look, we want to measure our boxes and make comparative statements on a maximum operating condition with, you know, drop rates, you know, at whatever drop rate physical layers would drop after hitting line rate. If you could cram your upstream with all upstream full line rate. And that's not how networks are provisioned and used in the actual real world. So what we drove was the behavior of the way in which customers, our customers, use networks is the way in which we wanted them to compare product to product. So that was the difficulty in power measurement. But the actual point of that load, there's no difficulty in actually getting the power reading.
What is the estimation aspect? You're talking about measurement, but you mentioned in your slide estimation. How do you estimate the power?
Oh, I'm sorry. So you're talking. I'm talking about gate power in an ASIC structure. Sorry, mistook your question. I thought you. Yeah. So that was in the actual ASIC design. So it's the tools that they're given during the development and design of the ASIC. That generally comes from the vendor. And those power estimation tools don't necessarily give them solid results that they're very confident with. And during that development, what generally happens is they will pad that number because they don't want a device coming back from Foundry that exceeds the level that they've told the board designer, and then the board designer tells the power engineer for board mounted power. He adds his pad, and then that board then becomes a number that is padded again when the system level adds up all the line cards in that multi-line card chassis. So what happens is that small amount of buffer at the ASIC that gets added to, you know, all the way up to the you know, central power system, and then when we plug it all together, sometimes it comes in, you know, running at, you know, 50% of the load on the main system, and that's not what we want any longer. We want much higher utilization.
Okay, thanks again, Joe.
Thank you.